Hello and welcome to today's video. So on the workbench today we have an AMC325. This one is serial number 1247. It is in for a reprogram and I guess a test. We'll go ahead and test it, make sure it all works after that. The customer sent it in. He was unable to program it, so we want to make sure that there's nothing wrong with its RS422 interface here. He did have he purchased one of my, what do I call this? The RS232 to RS422 AMC serial adapter, which I apparently made back in 2015, and wasn't able to get to work. So we're going to go ahead and try it with my setup here. This is my USB to serial adapter. It is just a standard generic prolific USB to serial adapter. The prolific and FTDI ones work perfectly fine. The cheaper CH340s, which sometimes they'll print 340 on them like that, do not work. The drive communicates at 4800 baud, and these only go down to 9600 baud. So they won't work. So if that could have been the problem. If he was trying to use a CH340 based USB to serial adapter, the really cheap ones that you find on eBay or Amazon, they don't work. They won't work in this application. So you have to use a more expensive prolific or an FTDI based USB to serial adapter. Just make sure it supports 4800 baud. So yeah, the only difference in my setup than a normal setup is I do have the USB isolator in line here. The main reason for that is I am running off the Variac, and that is going into the capacitor of doom, which I've built a nice little stand for it. And you might notice there's a lot of empty space over here because I want to put a voltmeter and maybe a fuse holder instead of having the fuse like in line. But anyways, besides the point. The reason I have the USB isolator is because there's about, we're running at whatever I've got it set at 120 volts AC. So we've got about 60 volt AC between everything and ground. So if you didn't have the isolator and you plugged the USB from here directly into my laptop, that would actually cause about a lot of current to flow, and you'll typically pop these very quickly. If you don't believe me, here you go, watch this. We'll just turn this on. We'll put it in AC mode instead of DC. And let me see. Oh, hold on. I got the tripod here. We'll grab that because I won't be able to hold both at the same time. So hold on. Go for a little bit of a ride here. And there you go. Okay. Ooh, well, hold on. Let me see if I can get the motor and laptop in frame? Yes. Okay. So what we're going to do is simply go into the port on the laptop here. I'm just touching the frame, and we're going to touch the motor. What do we got? 55 volts? Yeah. 55 volts AC, or 54.8 volts AC. So yeah, if you were without the isolator, you would be subjecting the USB to serial adapter to a lot of voltage. So this isn't a problem if you're running it off of DC, if you're just connecting. It's just that I have my laptop plugged into the same wall, same plug back there. It's that black plug right there. And that's because the battery in this is completely dead. But anyways, he can see down. Actually, let me take this off the tripod here. So yeah, you can see my battery is physically completely dead. So I can't run this laptop off battery. It always has to be plugged in. And the reason I'm using this laptop is because it's old, and it's 32-bit Windows, which is what's necessary to run the AMC application that we're going to use to program this. The other thing to check is to make sure that your USB to serial adapter, we can get it to focus here. Focus. Come on, you can focus. Look, my hand's really close. There you go. Is set to COM1. Ah, really? Hold on, let me turn off the light. Is that the problem? Did it not like that? Okay, you can see that prolific USB serial adapter is on COM1. That's the other thing. Sometimes when you plug in the USB to serial adapters, it assigns them the weird COM numbers like 5, 6, 7, 8, 9. Who knows? You definitely want it set to COM1 or COM2 to run the AMC program. So other than that, yeah, that's pretty much the entire setup. So normally you wouldn't have the USB isolator. I have that just because of my setup that I've got, because I don't have my bidirectional buck boost converter up and running yet, which one of these days I'll get that running. So yeah, you just plug the RS422 to RS232 adapter in, and then look inside the drive here. It goes into the port. See that port down there, and it looks like it goes in that direction. So I'll just bear with me for a second here while I squeeze this in here and just find where that wants to be, and we'll plug it in. So it's really hard to do while holding the camera up. There you go, got it. And then just kind of squish it in there, and yeah, so now that's plugged in. So you do have to take the side panel off to get to it, unless you modify it to bring that connection out. But yeah, so that's it. So we got that plugged in. We've got that. We got the drive going, ready to go. And the next step is we don't really need this up. Kill that. Don't need this. This is an old Vista laptop, but the key is that it's 32 bits. So we're going to run our get to a command prompt, and let me turn the light off. Let me see, there you go, because it seems the light to lose focus. And I might actually, let's put this back on the tripod. If I ever took the time to edit these videos, I could edit all this stuff out, but nah, there's a leg from the workbench that's in the way, so that's as close as I can get. So we're going to go to the Bursa directory, and then we're going to go to the AMC program, and I don't remember what it's called. Yeah, that's it. So we're going to launch that, and it's going to tell us to turn on the drive. I'm going to flip that on, hit any key, and it's going to connect to it. And we're going to read out the drive, and we're going to view the drive, and those are the settings for this particular one. And he wants the I wrote it down because I'm using my cell phone, which has the email on it, to what voltage. He wants it set to 144 volts to 205 volts. Can I zoom in on this while it's running? Oh, I can! Oh, it looks terrible. But maybe that's easier. I don't know. Maybe if I... anyways, that looks pretty bad. One of these days, maybe I'll get an actual real camera instead of using my cell phone. But anyways, all we do is we scroll over to the voltages here. So what we got? We got 132 is currently the low end. 134 is the when the LED turns on. 188 is the high voltage LED, and then 190 is the high voltage limit. So looks like they just put it a volt or 2 volts away. So we want the high end to be 205 now. So I'll change that to 205, and then we'll make this one 203. So we maintain that 2 voltages below, or 2 volts under. And then the low end, you wanted 144 volts, so we can do that. And then we'll put this at 146, so that our LED will turn on to tell you that the battery's low. Yeah, that's it. So after that, we go to the next page. We're going to write that data to the drive, and it'll do it here, and it's done. So if we were to exit, no, we don't want to save it. This would save it to my hard drive. This isn't, we've already saved it to the drive. So that we can come back in, and we gotta flip it off, turn it back on, hit any key. So these aren't difficult to program. I think we'll go ahead and read it out. I think the most difficult part is just actually getting the serial stuff to work. You pretty much need an old laptop, 32-bit Windows version, or a more modern laptop but run DOSBox or something on there. But you can see that the files, I mean, we power cycled the drive, and it's now 144 volts, 146, 203, and 205. So that's it. We'll go ahead and exit this. So hit F10 to exit, and we can run the Monlog program. And I think we got to power cycle it again too. Turn it back on, and this will connect. Maybe, there it goes. And then this is an AMC325, so we want to hit G. And there, now we got all the real-time data is coming across. So, oh, that is so horribly out of focus. Sorry if you missed all that, but you can kind of see there's stuff going on across. So right now it thinks the voltage, we're sitting at 169 volts. Let me actually measure my DC bus so you can see how close we are. If it's off by a lot, that can be adjusted, but typically they're pretty close. I'll go ahead and measure that. Even though you can't see, I will tell you that it is at 169.6. Actually, you know what? We'll just cram the probes in here and see if we can't show you that here in a second. There you go. Okay. So yeah, it I don't know if you can read that. It says 169. Let me zoom back out. How did I do that? There you go. There. Take this back off. So maybe it's easier if I do that. So it says it's 169.5 volts. And if we look at the voltmeter, 169.6. So yeah, it's like dead on. And you can see I'm just measuring the DC bus by sticking the probes into the capacitor of doom. So yeah, that's not working. So if we go ahead, and the drive is on, so we can go ahead and put it in gear, and we can give it a little bit of throttle, and she spins. So we can go into reverse and give it a little, help it spin down here. And then we can go in reverse. So it's nice and smooth. So this drive looks like it all works. He just wanted it to be reprogrammed to a different voltage level. The only interesting thing that I did find is this drive has got a phase swapped in it. So inside here there's a little A-B switch. The switch is flipped from the A position to the B position. And I had to swap two of my phases to make it work with my motor. So if you were trying to reprogram it because it wasn't running the motor right, double check your motor phases. Something's swapped. This drive is not standard. But yeah, other than that, one thing we should try, we changed the voltage limit to 205. I don't think I can get up that high with this. Let me check. Let me see what, I'm going to go ahead and turn this up. And when we hit, so right now we don't have, let me put it in gear. So we have no full or low lights coming on, LEDs. So we're going to crank this up. We set it to 205, so we'll see if we can't get the light to come on. I'm not 100% sure if I can get up to 200. Nope. I can't get there. I can get to 200. I can get 199. I've maxed it out. I need to get a 240 volt Variac. I can't go any higher. Already maxed out. Shoot. Well, I would have expected the full light to come on at 203 volts, but you can't actually get up there. We can check the low end though. We had changed it to 144 volts, so if I go ahead and drop that down, it takes a little bit to decay. Actually, what we'll do is we'll make it spin a little bit. We'll make it burn some power. There we go. That'll make it decay quicker. So we're at, yeah, let me crank this up a little bit. So you can see, let me turn this down so we're not spinning. Not trying to spin. So we're at 148 volts. And you can see we got no lights on. And I'm going to slowly turn this down. And there you go. The LED came on saying that our battery is empty. And that's because we're down at 120 volts. But let me turn that back up. If I turn it to 1, we set the limit. Yeah, okay, so we're at 146 volts is where we set the empty limit, and we're at 145 volts. You can see the LED is on. Actually, hold on. Let's do this. Let's bring that. There you go. You can see both now. So I'm going to start turning it up just a little bit. 147. And the LED went off. So I would assume the high end's also working fine. So the program definitely took. And yeah, she's ready to go. Thanks for watching. Bye.